Okay, so chapter 5 is all about the applying all the derivatives that we've been doing. All right, so I need you, go ahead and copy down the definition. So everything in this section is going to be applying the derivative to graphs and understanding graphs. So we're going to see an absolute max on a graph if all the y values are less than or equal to the maximum. To me, they kind of do this a little backwards, but you'll see what this says in just a second. So we say absolute or global if it's the highest or lowest point on the entire graph. All right, so for example, if we consider just sine of x, cosine of x. If I look from f of x equals cosine from negative pi over 2 to pi over 2, this is the absolute highest point. So we say there's a maximum value of 1 at x equals 0. Then these are minimum values. The values are the y values. There's a minimum value of 0 at x equals pi over 2 and negative pi over 2. All right, then we look at sine from negative pi over 2 to pi over 2. This is the min, and this is the max. This is the max because all other y values are lower than the maximum. This is the minimum because all the other y values are higher than the minimum. So we say there's a max value of 1, this is the y value, at x equals pi over 2. And there's a minimum value of negative 1 at negative pi over 2. Okay. All right, so let's just look at x squared on many different domains. All right, so if I look at the entire graph, the entire graph goes on forever and ever and ever, right? So can you see, because it goes up forever, there is no max from infinity to infinity. There's a minimum, though, of this coordinate point here is 0, 0. The minimum occurs at the y value. There's a min of 0 at x equals 0. Now, let's consider this domain. Notice this is a closed interval from where x equals 0 to where x equals 2. So if I plug, this should be a coordinate. If I plug 2 into x squared, I get 4. So if I'm just looking for here to here, do you see how this is the highest point? This is the lowest point. So there's a max of 4, the y value, at x equals 2. And there's a min of 0 at x equals 0. Now what happens if there's a hole here? where it's everything getting close to 0, but it does not include 0. So I can't find that lowest point because I can't get close enough to 0. So if this is an open interval, there can't be a max or a min at that open interval. So here there's no minimum because there's a hole. But the max is still 4 at x equals 2. So what happens when both the intervals are open? So there's a hole at both places. So I can't get to the lowest point and I can't get to the highest point. Because remember, these don't exist here, right? When I have my closed and open intervals, I'm just looking at from here to here. So this one has no min because the open interval, and no max because this is also an open interval. So for it to have a max and a min, it has to be closed. And that's the extreme value theorem. First of all, it has to be a continuous function and it has to be closed. Then we're guaranteed both a max and a min. So what I did is just kind of label these points. This is a max of m at x equals x2. This is a min of lowercase m at x equals x1. So max and mins can occur on the interior points. They can also occur at endpoints. Max, min. So this one has a max at an interior point and a min at an endpoint. So this is just showing all the different possibilities. And if you have room, I just kind of did a sketch of this next to the other graphs. And it's showing the difference between an absolute, so there's nothing below this on the whole graph. This is the absolute max, which you need, kiddo. Huh? Oh, okay. So absolutes mean nothing else is above or below. So absolute min, nothing else is below this on the graph. Absolute max, nothing else is above. But see how this is high, the highest point is the top of a hill? We call that a local max because it's the highest point in that area. This is a local min because it's the lowest spot nearby or in that area. And this is also a local min because it's the lowest point in. So if you can draw like a circle and it's the highest or lowest point, that's a local. Absolute means nothing else can be below it or nothing else can be above it. All right, so then that's just defining what local extreme values are. So if you want to go ahead and copy that. Maybe pause the video so then you can get all of that. So when you're looking at graphs, it's pretty obvious where the high points and low points are. What gets tough is when you just have the equation. See, calc was really invented or discovered, whatever you want to say, because it gives us a better understanding of graphs. Think back to a long time ago, we didn't have graphing calculators. I never had a graphing calculator until I started teaching. So what calculus does is finds everything out about graphs that we don't know. So if you look back here, does it make sense that high points occur at zero slopes? Low points occur at zero slopes. So that's the local extreme value theorem number 2. Local max and mins can occur when the derivative equals 0, when the slope is 0. Now, what it says about a critical point is we might have a 0 slope or a slope that does not exist. Those identify to us critical points where we might have max and mins, but we're not guaranteed that. So let's think about the does not exist. See here, this is a cusp. At a corner or a cusp, we can have a high point or low point. So the two things we're going to be looking for in the equation is where the derivative equals 0 and where the derivative does not exist. That's how we identify critical points in our graph. This just says we're going to call this specifically a stationary point when the derivative equals 0. Okay. So this just says find the absolute min and max. The first thing I want you to write though, where do I see a critical point? See how there's a cusp here? F of 0 equals 0. This is a critical point because it's a cusp. Oh, and you might need to graph this. So this coordinate point, -2, -2 to the 2/3. It can be negative because that's the cube root, so that's okay. And this point here is, plug in 3 to the 2/3. So we have 3 points here on our graph that are key. The critical points just where the derivative does not exist or where it equals 0. So this is my only critical point because this is a cusp. And remember, we can also find our mins and maxes can also occur at endpoints. So I'm going to look at my endpoints. So when I plug in -2, that's what I was doing on the graph. I got -2 to the 2/3. Does it make sense that this is like the cube root of -2 squared, which is 4? And if I plug in 3 to the 2/3 is the cube root of 9. So I can compare these two and see that this is higher. So what is my absolute max? This is the highest point on this interval. Now, I am going to say it has to be closed in order to guarantee that we have a max and a min. So we have a max of, that's where we use our y value, the cube root of 9 at x equals 3. So this is our maximum point. We say this is the max value at x equals 3. There's a minimum. What's the min? Is 0, 0. That's our cusp. Min of 0 at x equals 0. Now we can also, this just says absolutes, but I'm going to qualify this as a local max because this is the high point in that area of the cube root of 4 at x equals -2. So look for your critical points, look for your endpoints, and that's where you're going to find your max and mins. All right, here's another graph you want to put in. If you graph this on your graphing calculator though, it looks like these are endpoints. But if I plug -2 in, look at the equation. -2 squared, that's just 4 minus 4. I get 0 in the denominator. This is an open circle at both -2 and 2. And you have to look at your equation to see that. So that means this has no max because this is open at the end. So we cannot find the highest point. And what is f of 0? If I plug 0 in for x, I get 1 over square root of 4 is 2. So we have a min of 1/2 at x equals 0. Now, these are just giving you general ideas about this section. We're going to work through a lot of homework together, so be patient. This shows you 2 places that we have critical points because at 0, we have the slope. This is a 0 slope, but this is not a high or low point because it's in the middle. What is this? This is a vertical tangent. So this is where f prime does not exist because a vertical tangent, that's what that means. But this is also not a high or low point around it. So these are just cases where critical points are not extreme. All right, so let's look at an equation. First, I'm going to graph it because this is something that we can graph. How do I graph? This is an upside down parabola. So like if I plug in 0, I go up 5. Look for the ones you're comfortable with. Start with those. Yep, good one. And I'm going to use this until I get to 1. So if I find my y value at 1, at 1 it's 3. Notice this is a closed circle. Now I'm going to use this one. This is just a line. I'm going to plug 1 in here. F of 1 here is also 3. So this one starts, this starts where this leaves off. But this is a line with slope 1, up 1 over 1. So this is what the graph looks like. Notice how it goes down forever on this side, up forever on this side. So there's no absolutes, no absolute max or min. But this is a corner because the derivative is different from the left than it is from the right. So this f prime does not exist at 1. So that means it's a critical point. And it means it's a local min. Local because there's other points that are lower. But in this area, it's the lowest point of, what's the value? 3. And that's at x equals 1. All right, last problem. So this says using graphical methods. So if we look at this complicated equation, you want to graph this using your graphing calculator. So first you need to type in ln in your y equals, and then do the absolute value, and the abs is under math, and then go to number, and that gives you this inside. Then create your fraction bar, alpha, the green, y equals, that gives you numerator over denominator, plug everything in and graph it. And this is what it looks like. So after you graph it, you're going to find the maximum points of the graph. So it looks like here and here, looks like we've got some maxes. So this is where you hit second calculate. You want the calculator to find maximum values. And it'll say left. So you put it on the left side before it gets to the max. Then it says the right. So cross and start to go back down. You want the max to be in between the two cursors. Always just hit enter for guess, because who cares? And you should find a max of, what's the y value? Negative 0.6931 at x equals, and it ends up being both positive and -1. This occurs at both, this same y value is both a +1 and -1. And this is our answer.